Good morning, everyone. Thank you for joining us. John Nance and I are excited today to talk to you about new products that are launching. One that has officially launched already, the other one very shortly to come. But today we want to just spend about 20-30 minutes going over some of the details about these new products so you guys were aware of how to address things in the field. Obviously, you're going to need to know the ins and the outs of these products, what our competition looks like, what are the applications for this, and that's what we're hoping to cover today. During the presentation, John and I will kind of be trading off a little bit. He'll obviously cover more of the technical stuff, and I'll give you a little bit more of the selling parts that may help you out in the field. So this is kind of a quick little overview of the agenda that we're hoping to accomplish today. If you should have questions that arise at any time, feel free to type those into the question box. We'll try and circle back to all of those at the end of the presentation, and hopefully we can get anything addressed at that time. For those that are participating for your agency, please know we are going to be recording this. And we will send out a link later, hopefully today, if not the very latest, hopefully Monday, where we will share this information and hopefully they can view at their leisure. At this time, I'm going to turn it over to John Nance, who will get this started for us. John?
Thanks, Angelo. So, like you said, my name is John Nance, an engineer here at Prier. And for better or for worse, I'm the designer of these two new products, so we'll go into detail here a little more about them. Okay, so to start, the first product is the RH4. It's the sanitary roof hydrant, and that is released and it's ready as today and for the future. So the whole premise behind this is, basically just a rooftop hydrant that is going to give excess water to any rooftop, equipment that needs maintained, or solar panels, cooling towers, any of that kind of stuff. So, but in addition to not only having access to water on the roof, but it's going to provide a frost-proof way of doing this too, so you're not going to have any issues during freezing temperatures. On the flip side, the ground hydrant, that's the P360. It's not quite ready. It'll be ready early 2022, but they both share a lot of the same designs and same principles within them. So now, of course, where each of these are used, like I mentioned, the roof hydrant itself is really going to be installed anywhere where there's some type of rooftop equipment. So whether that's a popular one is air conditioning units, solar panels are becoming more popular. A lot of restaurants have exhaust fans, that type of thing. But the nice thing about these roof hydrants is traditionally to become frost proof, they need to be able to drain the water from the riser, or where the water would come out of the spout. It needs to drain and evacuate all that water so that it can't freeze and harm the hydrant. The issue with that on the roof is there's not many drains in the roof, and if they are, a lot of times it might be a long ways to get to an adequate drain, within the building somewhere. So that can be costly. Whereas a sanitary roof hydrant, that'll combat that nicely and make it so that roof is no longer, or that drain is no longer required. Now the P360, the ground side, these are going to be used at various places, agricultural uses. A lot of campgrounds are requiring the ASSE 1057 sanitary approved hydrants. But really the whole premise is similar for any yard hydrant. It's where water access is needed where there's not some type of warm enclosure. So you're wanting to have water access away from a heated building or something like that. So you have to use the warmer temperature from the earth below the soil to be able to protect the hydrant during the freezing conditions. So that's a little bit about where they're used and kind of the reason for having each of those. Now to go into a little more detail on the actual sanitary aspects of them, the roof and the Berry hydrant, they're both considered sanitary ground hydrants, and they're both approved to ASSE 1057. But some of the benefits of them are particular to each other. For the roof aspect, of course, like I said, we don't need to run a drain line. So you can install this hydrant anywhere, and it'll all drain within the hydrant itself. So it doesn't need a drain line run. And there's not the extra cost of not only drain line, but the labor to run that drain line. We have made a couple late adjustments to the roof. I guess late as in a few months ago, but a few new improvements to this hydrant. We've learned that in a lot of commercial roof settings, there's a lot more codes and regulations that go into those than what maybe our original spec realized. So we now have metal inlets, a metal riser, and all that is to pass the 2550 rule, the smoke versus flame index rules that apply to most commercial roof buildings. So this hydrant would be able to install anywhere throughout a roof. We didn't want to limit our application anywhere. We wanted this to be used anywhere that it might be needed. So it can be used in a plenum in any commercial roof. So now on the Berry side, the sanitary aspect, it's really where the 1057 code was developed around, was more on the Berry aspect of these sanitary hydrants. And the reason being that traditionally we mentioned that whenever a ground hydrant is shut off, all that water needs to drain from the riser, and it drains out a weep hole at the bottom of the hydrant. And then that evacuates all the water from the riser, and therefore the hydrant can't freeze. So that's good. The only issue with that is that if water is able to exit the hydrant, water is also able to enter the hydrant. So if you're in an area that has a high water table, any type of, I've heard a lot about fertilizers, that might leach down through the ground. Any type of contaminants that are in the soil or in the water table, they have the potential to be siphoned into the hydrant and therefore into the water supply. So that's really the main reason why this whole 1057 code was developed and why these products are in existence. So our hydrant in particular, we went as maintenance free as possible. So we know that once these are installed, if you can just use them for what their purpose is and they don't require babysitting all the time, that's the best case scenario, right? So we've used a piston type design. No winterization is required. Angela will go into more detail on this later, but basically it's a 1-for-1, I guess, ratio. So you'll learn more about it later. So for functionality wise, there's a low and high flow settings. I know customers have asked for a bucket hook. So they're used on, more agricultural commercial settings where you're going to hang a bucket off of these hydrants. We've made that a little bit bigger now. And then last thing we've made a little better too is we've used a next grade of cast iron that's called ductile iron versus traditionally gray cast iron has been used. So where ductile cast iron, it has about 3 times the tensile strength of what gray does. So just a lot beefier, stronger, more heavy duty. So, and then specifications, these are all pertaining to ASSE 1057 that these 2 hydrants are approved to. The flow required is only 6 gallons a minute, but our hydrant will flow about 10 gallons a minute. The temperature rating of this is 140 degrees Fahrenheit. And the pressure is a maximum of 100 PSI working pressure. So, and of course, some of these can vary. That's really what they're rated to. So if you ever have an application that's outside of these parameters, always feel free to call in and we can look at that specific application and see how, this hydrant will fare. So a lot of the information's on the website. So there's spec sheets, installation, operation, and maintenance manuals are on the website, BIM and Revit files. So all that information is out there and available. So here's a little video kind of showing a little bit how the hydrant functions. Really, to the user, it's not going to be any different than what we've known in the past. The biggest benefit's going to be really to the to the installation crew and the maintenance in future, down the road. The maintenance of this hydrant is pretty simple. There you can kind of see a low and high flow setting. So to discuss a little bit more about this and in depth, I'll turn it back over to Angelo here.
All right, thank you, John. Obviously for you guys, technical stuff helps. That's why we want to have John kind of give us a little assist here. But you guys are kind of curious, what are we up against in the industry? I mean, obviously we're up against the old frost-proof design that John had talked about, where you are required to have that drain line for something like a roof application. That could take a plumber 15 yards to hit a drain port, or that could be 100 yards. How many are on the roof? You may have to run 10, 15 different drain lines to hit drain ports. So we're up against the old style, which requires that drain down system. Also for the ground application as well, like John was talking about, where you essentially have an open port that could get contaminants in. So, one thing I always like to point out is, both of these are classified as a sanitary, and John kind of hinted on it before. There is no real sanitary application in the roof part of the design, because there's nothing there in that space that can leach into the hydrant. The sanitary part actually is more pertained to the yard part of it, the ground, that you're going to have anything buried. But with the sanitary roof part, that's simply no drain line. You don't have to worry about it. I mean, we've heard horror stories where either the plumber just forgot all about it, didn't even plumb anything to it. So big issue whenever they turn off the hydrant and all that water drains and gets all over the ceiling tile, or if there's nothing there, it just falls all the way down to the floor. So and then we've even heard stories about plumbers just plugging the thing up. Well, no longer is it frostproof. So you hear a mix of these, and I think engineers have kind of run into this more times than they would like to. And that's what kind of led to this kind of concept of having a sanitary versus one of these old ways of having that drain port. So there are a couple designs already out in the industry today. Our bigger competitor is obviously Woodford. They've had a sanitary roof hydrant and a sanitary yard hydrant for some time. There's also one called Freeze Flow. But for us, these are the two main ones that are out there in the industry today that are doing something along these lines. So, it's not like we're competing with everybody that are making hydrants. There is a select few. So that gives us a strong opportunity to really jump out in front of some of these competitors. Now, we most definitely did our research, and we were looking at these competitors when we were designing this. And actually, there's two types of different sanitary hydrants, and it's mainly due to the displacement of the water. One of these designs is using what's called a Venturi system, and it's a siphonage system, and the other one's using a piston displacement system. So with the Venturi, we did a lot of research on this, and it uses a lot of siphonage. So there's a reservoir that sits down below in the heated space. When you turn the water off, that water is going to drain into that reservoir, and it sits in that reservoir until the next time you operate the valve. When you turn that valve back on, water is going to flow through the middle of the pipe. So it goes around the plunger, it flows straight through. And during this, it actually is creating a siphonage or a vacuum. And it's actually creating a draw that is pulling water out of that canister, and it's sucking it up with the flow water. It works well. But one of the things that we didn't like was it takes a while for it actually to drain that canister, especially more on a yard hydrant. If you have a 3-foot, 4-foot bury, you could take up to a minute to completely drain a Venturi system. One of the things that we did see in the market was more of a piston style, and this is what we gravitated to with a design. Is we went to the piston because it's an immediate water displacement. So essentially, the second you turn it on, that is going to push the little piston, which is kind of right here in the middle. You'll see there is, I'm trying to get my mouse to work here. There's O-rings right here on this little piston here. This is your operating rod and your flow. So the water is going to come up through the middle, and it runs all the way up through here. But with this is your reservoir that's going to hold the water underneath the heated space. And when you turn the valve on, it's going to push this rod down. And when it pushes this rod down, this piston is going to compress all the water that sits in this area, and it's going to go right up through the middle of this and out the hose piece. What we liked about it is it requires no winterization. So if you go back to the Venturi style, there are certain things that you have to do to make it operate properly. In fact, I'm going to read you directly from one of our competitors' spec sheets or tech notes that they had on their website that is using the Venturi system. It says, when the hydrant is turned off, the plunger is moved to the closed position. At this point, the reservoir is full, along with the head and the operating pipe. At this point, the hydrant is not frost-proof. So it's essentially saying that with the Venturi style, even when it's closed, you don't have a frost-proof hydrant. Well, guys, we're building a frost-proof hydrant here. We need to make sure it's frost-proof. So one of the disadvantages to the Venturi style is it requires winterization. And let's face it, the engineer may know this, the plumber may know this, but neither one of them are there during operation. It's going to be a service guy or a building owner. They are probably not aware that there are certain requirements for the Venturi style to be a frost-proof. It has to be winterized. And in their information, their IOM on that Venturi style, it says that you must turn the valve off. Then you have to disconnect the hose, and then you have to turn it back on, and you have to run it for a certain period of time, and then you have to close it. That's the winterization aspect of it. Unfortunately, you're not going to get a lot of people that are aware of this, and heck, you might not even get a lot of them that are even going to disconnect the hose. With the piston style that we design, when you close the valve, even with the hose still attached, you will always be frost-proof. So now we no longer have to worry about the maintenance guy remembering to disconnect the hose to make it winterized. So that's a huge advantage over this Venturi style. And another thing that came about too with some of our competitors, and this is more on the sanitary yard part of it. One of the biggest complaints that we have is some of our competitors have what's called a little diverter piece right here underneath the neck of the valve. And when you turn the valve on, water does not come out of this. It's going to spray out of this little section right here. And in order for you to divert the water to the hose piece, you must pull down on that diverter while it's in the open position, meaning you're sticking your hand right up there where there's running water, pulling that diverter piece down to send the water over to the hose piece. Now let's use this sanitary application. Many of these are designed for RV parks, national parks, marinas, things where we need to make sure that the water is for potable use. RV parks, they're hooking these things up so they're drinking out of the water, they're bathing with the water, they're supplying all these sources to the RV. They need to be able to have a sanitary application. Well, the thing with RV parks and state parks, you have a lot of turnover. There's people coming in and out on a regular basis. If they are not familiar with this particular application, when they turn this on, they're calling somebody saying, my yard hydrant's broke, I can't get water to my supply line. And typically the maintenance guys on site are going to say, you got to pull that little diverter piece. That's what happens. And every time you turn it off, that diverter will always need to be re-engaged. We stayed away from that. With using this piston style and our vacuum breaker design, we have no diverter pieces on either the roof hydrant or the yard hydrant. It's another huge advantage over some of our competition. So, that's a couple key benefits that we think are huge distinguishing factors. The style of the water displacement, Venturi versus piston. We believe the piston is the better opportunity, which is why we went that avenue. We got rid of the requirement to remove a hose. No longer is that needed. And, we can also make sure that there's no diverter needed where the end user's having to worry about diverting the water off to the other source.
Hey, Angela, before you move on,
Yep.
on that, so one more benefit too, we're talking when you mentioned the RV parks and potable water. So the water that is sitting in that canister in the piston design, as it gets squeegeed out and put back into the flow path, the water that's in the canister is actually the first to go back into the flow path, and it'll be the first to exit also, the hydrant. So the water that's been hanging out in that canister for a while, it was a nice benefit that was the first that's going to exit the hydrant too. So you're going to get fresh water, almost
Within a second or two.
right.
So, and that's also that, if going back to that Venturi style, you're going to be getting, let's just say, reservoir water for 30 seconds to a minute, depending on what type of length you have. And it's just blended in with the fresh water that's coming in. So again, it was just an advantage of using the piston style. And now, regarding the installation, we stayed with on the roof application, we stayed with our standard mounting bracket. So we did have one small adjustment with our sanitary roof hydrants. The bracketing system needed to be a little larger. Obviously, you have a much wider base where we are connecting the unit. And so we had to have larger clamps. So what we ended up doing is all of our hydrants, all of our roof hydrants all get sent with a mounting bracket. So all of those are automatically included. No special, add-ons or anything are needed. Everything will come with the mounting bracket. And we include both of the mounting brackets. So you're going to have one for the narrow and you're going to have the wider application to mount. Now, another advantage to this is our connection. So we are different than anybody else in the industry where, most of the industry is going to take their mounting bracket and they're going to attach it up to the decking of the roof. This is the norm. Now when Prier was looking at designing these roof hydrants, we did something that was a little unheard of. We actually went around and we asked some people, and we asked some questions, and one of the most important people you could probably ask when it comes to a roof application is, we talked to a roofing contractor here in Kansas City, and one of our lead engineers, Scott Brady here, he was actually working with a roofing contractor, and he asked him, how would you install this? And, just talking about a roof hydrant in general. Well, the roofing contractor looks at him and he smiles. He goes, you know what? I'm glad you asked. He goes, we run into these things fairly often where they're leaking. And he goes, any roofer will tell you, stop drilling holes in my horizontal roof. We want as little holes, little penetrations as possible. He goes, these mounting brackets that everybody's attaching is using anywhere from 4 to 6 lag bolts to screw it down into the membrane of the roof itself. Well, they said, well, here's your issue is you have a hydrant that's going to sit about 3 foot, 4 foot up off the roof line. If you get a big old boy yanking on that hose, trying to get an extra inch out of it to wash down that condenser, he's essentially going to cantilever that bracketing system up off the membrane of the roof. He goes, or even worse yet, you put it too close to an access point and you got somebody trying to crawl out of an access point and they see a nice sturdy hydrant right there next to the access point. They're going to grab that thing to hoist themselves up onto the actual roof line. And he goes, all of this is just going to essentially lead to those bolts being pried loose and they form a leak point. He goes, we've had to replace and repair a good deal of these. And he goes, what we would strongly recommend is do the same thing we do with everything else. Look at all these, units up here, these HVAC units, these cooling towers, these solar panels. We mount nothing to the decking of the roof. Everything is going down below to a more structured part of the building. That's your I-beams, that's your trusses. And we're mounting everything there. He goes, when you're walking on a roof line, where do you typically try to step? Do you try and step on the supports or do you try and step where there's not support? He goes, you always want to go where there's a stronger support system. So that just made a lot of sense to us. So our mounting brackets are going to mount to that rigid part of the building, your I-beams, your trusses, and it's the same for these new sanitary hydrants as well. So you're going to have a 1-inch female pipe thread, and your outlet is obviously always going to be the same. It's a 3/4 inch outlet on the top. Like John had said before, with 10 gallons per minute at 25 PSI, you're going to get some serious flow through this inlet and this outlet.
So that's a 3 5/8 inch installation hole. I know that's important as well.
Absolutely. Yeah. I mean, obviously, we looked at several different things and, you never want to tell a plumber to drill a big giant hole into a roof. So we wanted to make it as small as possible. But again, this is a lot larger diameter pipe than what you're going to see with a standard frost-proof hydrant up there because we need that reservoir. And that reservoir is obviously going to be a wider structure. So you said 3 5/8. Yeah, and we wanted to make sure it was a standard hole saw bit that most plumbers are going to have on their, hopefully on their trucks. So it's a 3 5/8. And, too, we believe this is a pretty simple installation. We've had this conversation with a couple different guys. They say, really the biggest the biggest issue you may have is just making sure you know where to put it. Once you kind of figure out where it needs to go, you might have to measure over from this wall, measure it over from here. You're going to mount your bracket, and then you're going to use the mounting brackets to find a penetration hole up above. You drill a pilot hole through the bottom going up. Then the plumber can go up top. They can drill a hole straight down with that 3 5/8 inch, and then they're going to slide the hydrant down. Then they can go back down below and they can get it set up. So we most definitely wanted to make sure we were making it as easy as possible on the installation side. All this information is included on our IOMs for these products, which I believe get shipped with all of the hydrants themselves. And we are hoping that we will have a video soon because I know many plumbers like to watch a quick little tutorial video on how to do something instead of reading instructions. So hopefully we'll have that available as well. And then you're also on your installation for your Berry hydrant. The only thing that we recommend, obviously, both on the roof hydrant and on the Berry is your little guard cap that sits there at the top. This is where you're going to remove all the wearable components, which Sean's going to talk about here in a minute with the serviceability aspect. But that little cap, that little green cap that you can see here is labeled as the Earth Guard cap. This needs to be buried above the actual yard. In fact, we do have little labels on the roof and on the ground that says this is your roof line. And we want to make sure that that is always up above so you can make sure that's a removable aspect of the hydrant. We do not want to bury that. The Berry hydrants are going to come in obviously anything from a 1 foot to a 7 foot option. And one of the things we want to strongly encourage, these are actually very heavy products. So we want to make sure you have a good support system underneath. So when you are burying these, you probably are going to want to go maybe another foot or so below where you're actually going to connect. And we want to probably put a gravel base, possibly even a cinder block down there to help keep this hydrant supported, because it is a very heavy connection, and then you can backfill all that area. Again, this one's going to have a 1-inch connection, so we can still get some of those high flow rates. John, I'm going to turn it over to you to discuss these last couple things, and then we should be able to finish up here momentarily.
Yeah, so like Angelo mentioned, it is important to seal around, and that's both for the roof or the ground hydrant, but to not cover up that cap. And the reason being here is whenever you go to replace any of the, well, we talked about the O-rings that are inside of that canister that move the water, back up into the flow path. If on the roof, for instance, if we seal around this cap, end of the day, it's still okay because you're going to be able to break that seal, remove the cap, and still be able to get to your components. But the only issue is now you have to recreate this seal and then test it, and you're going through the whole, the whole factors of trying to create a good seal in the roof. So if that seal can be made around the galvanized pipe, you can avoid that. And just be able to take the cap off without breaking that seal. So with that being said, there's caps on both the roof and the ground hydrant. One for the ground hydrant is of course larger, just because if you're talking a 7-foot berry, that's going to contain a lot more water than, what a small roof hydrant would. So once you remove that cap, it's threaded on, and there's a hex provided there. Once you'll remove that, you can pull the entire head, and connected to that will be the stem beneath, and that whole rod will pull out of the housing or the body of the hydrant. And then from there, you'll be able to see what all of your O-rings are beneath. And we'll have an O-ring kit that basically we just recommend while you're already in there and while you've already got the hydrant apart to go ahead and replace all of the rubber components. It's about the same cost to do one as it is to do them all. So let's see. Once that stem and the head and all of that top portion come out, there are a few more steps, and they're all listed in the installation and maintenance manual, but there's a few more steps to take the stem itself actually out of that upper assembly. And then when it's being reinstalled, there's a procedure for how to set the stem length. So there's always variability, in tolerances and just how far things are screwed into each other, where everything bottoms out together. So we've included about a 1/4 inch to 3/8 of an inch adjustment within the stem. And there's a procedure in our manual on how to correctly set the stem length. And that'll just ensure that your hydrant is going to get the most amount of, it's opening all the way and it's going to get the most amount of flow it can, and that it's going to, drain correctly and contain water correctly. So, but we went to a lot of extra efforts to install and actually be at field installs to try to learn as much about how serviceability will work and how the installation aspect will work. And we've put a lot of time and effort into those installation manuals. And like Angelo said, we'll have an installation video coming soon that will give just a lot of the tips and tricks that we've learned. And every application is going to be a little different. I think everyone knows that, but there's a lot of good tips and stuff that we've learned, that we'll try to share with everyone too, just to make it as seamless as the whole process as seamless as possible. So kind of ties into the serviceability or some troubleshooting, you know, typical things that we could see coming up. And I'll run through these quickly. So maybe why is water leaking between the head and the galvanized pipe? So if we back up here, this would be leaking between the head, this section, and the galvanized pipe. That would be this upper riser. And that's gonna require a O-ring kit. So like we just discussed the procedure, you're gonna remove the top cap, pull the whole stem out, and replace all the, just go ahead and replace all the O-rings while you're there, and that'll fix your problem. Now that would be an O-ring specific to the head, more towards the top of the hydrant that's exposed. The next bullet point is, why does water continuously flow when the hydrant is shut off? This would also replace, would be replacing all the O-rings inside, but these would be pertaining more to the O-rings down at the bottom of the hydrant that would actually, are actually going to shut the inlet water supply off and on. So one good question, these couple at the bottom, just because it's really similar to a traditional roof or yard hydrant, but the fact that it is a sanitary hydrant and it contains all the drain water within it, there's quite a bit more going on the inside of these hydrants than what a traditional hydrant would have. So therefore they do operate a touch differently. So this next to last bullet point, why doesn't the hydrant flow water when the handle is barely raised? So if you raise this hydrant, say maybe a quarter to half of the way, no water is actually going to come out of the hydrant. And the reason being, if you think back to the image, we can go back to it later in our question section. But if you think back to the image of the piston in the canister, as that piston is traveling downward, the first half of the stroke of the handle is being used to pump that water out of the canister and back into the flow path. So then the last half of the stroke of the handle, that's actually used to flow water through the hydrant. So if you get any questions like, we're raising our handle some, but there's no water coming out, it's kind of the nature of the beast and just part of what these sanitary hydrants have. So another good question is, why does water come out of the spout when the hydrant is turned off? So like Angelo said, with or without a hose, the hydrant is always going to drain completely. And you'll notice that in the spout, it's pitched slightly downwards here. And so you might see a little bit of water coming out of that vacuum breaker and hose piece whenever the hydrant's shut off. And that's just getting rid of the remnant water that's left in the spout that's pitched downwards. So if we're looking at this image still, all the water that is up to the head and the spout where it starts, that'll drain down into the canister. And all the water that is, of course, it's not going to go back uphill. So all that water is going to have to drain out of the hose piece. And we've designed, you see quite a few of the components here that go into that hose piece. We've designed that so that it will work with a hose on, and it will allow water to drain when the hose is still on. And really into that hose piece too, I know we mentioned back before, this is a roof hydrant that's shown with the galvanized pipe. There's not as much of a sanitary application in the roof hydrant itself, but one thing to note, that 1057, ASSE 1057, it still includes all the safety aspects of what a lot of the ASSE codes cover. So even though there's not necessarily a big sanitary concern, there's still a backflow and a back siphonage concern, and that's what our vacuum breaker protects against. So I just wanted to mention that also. So I think that's it on the troubleshooting, and that kind of concludes our presentation. If there's any questions, Angela and I are both here. So
Yep, I'm gonna jump into MC here real quick. If anybody has questions, you will have either the chat function or the Q&A section. Either one of those works for us. But under the chat, we have, when using a sanitary hydrant, in a ground application. Oftentimes they're plumbed directly off of the main line and the PRV is bypassed. Water pressure can fluctuate well over 100 PSI. Could this be a potential problem? I mean, I would say absolutely. I mean, you run anything at a high PSI, it could easily cause problems. I know that per the code, we are saying that we're maximizing at 100 PSI. I think John may be able to add some input that I do believe that during the test, they may run it at even a higher rate. But we feel like a max of 100 PSI is the best way to limit, any rapid deterioration of the system, right? I mean, what kind of rating are they putting at the test cycle?
Yeah, so the code requires 100 PSI. And some of the tests within that require 125. And actually our pump in our lab, we use 150 PSI. So we do go above 100. I guess, if every application is a little different. So when it can fluctuate well over 100 PSI, we would, we need to look in what that well over is really defined by. And it could probably take a little more, but, of course, if it's a lot more, we designed this for, let's say, a 90-10 rule as far as a most normal application.
And like I said, obviously, this is just a standard that's put on by everybody. All manufacturers are hitting this. We are no different. So obviously we need to make sure that we are competing with what's out there. I think we probably could, like John said, live up to some of that pressure. But I think what would happen is eventually you're going to blow something. And that's going to be any plumbing system, right? Everything's going to be designed to max out at something before damages are going to be caused. I have a new response here. Equal to the Woodford SRH MS. How are we better? So the SRH MS is the Woodford Sanitary roof hydrant. This is the RH4, the one that we talked about just earlier. This is the one where we're better because, well, I don't want to use the word better. We're different because we use the piston style water displacement. We do not need to be winterized. In the specification of the Woodford, it specifically says hydrant must be winterized. You're putting a lot of faith in your maintenance guys to remember to go up there and remember to disconnect a hose, because Woodford's must be disconnected. Prier, you do not. So they could leave the hose on year round as long as they remember to shut the valve off. Then we would probably be okay. Woodford, you must turn it off. You must disconnect the hose. You must then turn the valve back on with no hose on, run it for a period of time, and then close it again for it all to be winterized. So we believe that removing the faith and the hope that the maintenance guys remembering to do this is an advantage. We are price competitive. In fact, I'm sure there's even a little bit of a savings over the Prier model versus the Woodford model. But we believe we have the better mousetrap, honestly. I think that ours is going to be a little bit better regarding the use, the serviceability, and then of course you go back to that install as well, where we have a little bit different of a mounting bracket that we believe provides a much more rigid support system. These valves are not light. I mean, if you look at what our engineering department has created, these are probably about 50-pound hydrants. They are a true robust thing. I would want these mounted to something that's pretty secure. So we feel that that's what makes us a little bit better than the Venturi style that Woodford is utilizing.
And Tom, I think that, the diverter that Woodford uses, that it seems to be, especially like from what you've seen, Angelo, in the field, is that can be kind of confusing too, just the way that it works. And whenever you shut the hydrant off, it always snaps back to where you have to keep enabling that all the time. So that can be kind of confusing too.
Yeah, and I think that one's probably more on the yard hydrant per se, but again, I think this is honestly something that we can hit up on the engineer level that is enough of a game changer on the engineer level to maybe get us going more on a basis of design. Pushing the fact that there's no winterization, no extra steps required, not remembering to disconnect a hose. All those things are working to our advantage that I think any engineer would probably tell you, yep, that makes a lot more sense. I should use that. And hopefully that leads us to more specifications and more use down the line. So I don't see any other questions, but again, feel free to chime in if you got anything here in the next minute or so. While we're wrapping up, I am going to let you guys know, obviously these products are fairly large. We do not have any intentions of sending out any samples or anything like that. You can always get with Scott or I to discuss some kind of option to get word out. I mean, obviously we're doing everything we can on the marketing end. They're doing emails, they're doing social media, we're doing blasts through all of our engineer database. We're trying to cover all of our angles to make sure we are acknowledging this new product, that we can get all this information out to everybody. But regarding, getting samples and stuff out, please know that it's not something we are intending to do. Again, these valves are very large, they're very heavy, but we want to support you all however we can. So please reach out if you have questions about finding ways to promote this within your territory. And then the side note too of production. I think Matt has indicated that we are caught up on our production side. So 95% of our orders are shipping in 8 working hours now, which is amazing. We're very happy to be back at our advertised ship rates. That we are going to ask if we get a little bit more lead time on these as they come in. Obviously, it's a new product for us. We're going to have manufacturing kind of take their time building these. We want to make sure they're built right and that we don't have any issues. So we are probably going to have a little smaller extended lead time on these types of sanitary roof hydrants going forward. You may be looking at closer to 3 to 5 business days. Now that may just be a little padding. We may be able to do it faster, but please communicate with your customers that there may be a smaller extended lead time on these versus a lot of our A items. But again, John kind of hinted on it before. The sanitary roof hydrant, the P-RH4, it's available today. We can begin selling these now. We are already getting some orders to come in. The P360, that is the yard hydrant. That one is not quite yet ready. It's going to be hopefully early 2022 that we'll be able to launch that. We've run into, no shock here, supply chain issues on getting some of those components in. It's kind of delayed some of our productivity on that side of it, but we are hoping to have that one launched soon. We will obviously do a big blitz on that to make sure you guys have everything you need. I had somebody ask if we can get this presentation. Absolutely. Again, later today, we will have a link, or I rephrase, it'll be later today or early Monday. We will have a link out to all of our reps that you guys can utilize this. Do you have a PowerPoint with notes that only a presenter can see? If not, can you make one? Yeah, we can probably work on that, Tom, with trying to get something set up that you guys could utilize. Maybe something very similar to what we did today, where we put some notes together for our reps to use, and we can load that to our rep portal to give you all the resources that you're going to need. I see, are we calling this Madden USA? I don't know if we're going to quite call it Madden USA, but I'll go with USA all day. So this new RH4, I think, guys, is going to be a huge home run for us. It was kind of one of the last little pieces that we were kind of missing on the commercial side. I think this is going to pay dividends for all of us. So I think we're going to have some strong sales growth with this. I think we have enough features and benefits that are going to differentiate us from our competition out there. I think that we are all going to have some success on this product. We're very excited about it. And again, if you guys need anything at all, feel free to reach out. We are happy to help any way we can. Thank you very much for joining us today. We will have a link out hopefully soon that your team that maybe missed out today can revisit. Thank you so much. Have a great day.